Welcome back to my garage. Tonight we are going to I am going to show you how to make a simple port map. I'm going to show you how I find the durations of the various ports, exhaust and transfer ports, and I am going to show you how I measure the angles or find the angles of the walls and roofs and floors of the ports. So let's get started. First I will show you how I make a simple port map. So the first thing I do when making a port map, and the way I make it is I put a piece of paper in the bore and I rub it, or rub with a pencil, to get all the outlines of the ports. So the first thing you need is a piece of paper, and I start with finding the rough length of the cylinder. So about 90 millimeters. So then I cut a piece of paper 90 millimeters long. So I mark 90 millimeters on both ends. I know my bore is 40 millimeters in diameter. Multiply 40 or 4 centimeters by pi times 3.14. That's 12.56. So then I measure 12.56 is there. Oops. Then I roll the paper and I slip it into the bore. And I leave my cylinder upside down on a flat surface, so it can line up with the top of the cylinder, or the deck. I take a piece of tape and I secure it to the bore in a couple of places. And then it's just a matter of going up and down and side to side inside the cylinder with a pencil, like this. Then all the port edges will show up. Like that. Then you just remove the tape and pull your rubbing or the port map out of the cylinder, and you end up with something like this, and that's the port map. Now you could use this to take, because now you know that the top of the cylinder is this edge, and then you could use this to measure the distances from the top edge to all your port, or to measure the port heights. You could use this to do that, but it's not super accurate because of the line and the pencil line and the rubbing there, and there could be a chamfer, or maybe the paper slipped a little bit when you pushed it in there, and also the it's not it's maybe your piston is stopping maybe half a millimeter short of the top edge of the cylinder, or a little bit above it. So you can't be sure just by if you haven't measured it before. You can't be sure, and it isn't totally accurate to do it this way. One way that is more accurate is to do exactly what I did with paper inside the cylinder, and then use a spray or a spray paint, rattle can, and spray into all the ports. And then you will get paint in or a painted outline of all the ports. The problem with that is that it is very hard to make it not, or make the paint not run, or keep it from running inside. What helps is to use a balloon and inflate it inside the bore with the paper there, so that you push the paper and seal around the ports. But I will show you my way, or how I measure the port durations with an indicator, and I think that's much more accurate and a better way to do it. What I do use the port map for though, and this is important if you are going to put the numbers, use the numbers in software. I use the port map to find the radiuses, the radii of all the ports. So for example, the upper radii of my exhaust port here, I use this hole template, and I find the hole that best matches my radii and radius. That's the hole, or maybe 7, I think 7 or even 6 millimeters. So that's a 6 millimeter hole, so that's a 3 millimeter radius. And I do that with all the ports and write it down. That's important if you are going to use it in software like Engmod 2-stroke, which need that as input. So that's primarily what I use port maps for. They're also useful just for comparing different cylinders, but not the best way of making port measurements like widths and heights and stuff like that. So okay, I will show you my way, or how I measure it with a dial gauge. Usually I do this with the engine assembled, so that the cylinder is sitting on the engine with the crank and the piston in it, so or assembled. The reason for this is that then I know that bottom dead center or top dead center is bottom dead center or top dead center. I don't have to calculate or guess or measure, or it's what my indicator picks up is what's going on in there. You don't need a fancy digital indicator like this. Perfectly fine with something like this, just an analog one, cheap one. Or you can get away with calipers, using them to measure down inside the board like that. Just make sure you keep them as straight as possible and flat against the wall. Or in a pinch, you can even just use a ruler. That's not very accurate. How I like to do this is I measure from bottom dead center instead of top dead center, which is the usual way to do it. The reason for this is that it's easy to find bottom dead center, true bottom dead center. You just have to, when it's the engine is assembled, you just put a little pressure on the piston when it's at the bottom, and you then I read off my indicator, and then I zero it when I know it's stable at bottom dead center. Because if you keep pressure on the piston, it will stay at the bottom. This is very important if you are going to use a caliper, because you need a reference, or bottom dead center is a better reference than top dead center, because it's hard to measure true top dead center with a caliper. This is no problem if you know that the piston is exactly flush with the cylinder top at top dead center, but often it is not. Okay, so let's pretend that my crank is, or the piston is on the crank, and let me see here, I'll put it into the bore here, and that it's at bottom dead center now. And I'll zero it, So then I know that this is the bottom dead center. What I then do is I use a piece of bent wire, 45 degrees bent wire, and I stick it down. If I want to measure the roof of say the auxiliary exhaust port, I put it down into the bore, parallel with the bore, sticking into the port, and then I bring the piston up to... wait a minute, I'm bottomed out. You hold it parallel to the bore, and then you bring the piston up to where it's touching, and then you read off your indicator. And mine says 13.4 millimeters. Since I'm measuring from bottom dead center, I take the 13.4 millimeters and I detract it from, subtract it from the bore, which is 39.1, and then I have to also subtract the thickness of my wire bent in 45 degrees. This is a 1.5 millimeter wire, so that's 2.2 millimeters. So I subtract that also, and that is, and then I get the distance from top dead center to port open, or the port floor. And I do this with all the ports. Okay, so now I'm going to show you how I measure the port roof angles. What you need is just a piece of solder and a angle finder. Not quite sure what this is. Protractor, says right there. So what I do is, and it's nice to have something to push the solder into the port with. So a pick of some kind. What I do is I have my cylinder upside down, or hold it upside down, and I bring the solder into the bore so that it's straight in line with the bore and overhanging one of the ports, and then I use the pick to push it into the port and up against the floor, or up against the roof, sorry. Okay, and I carefully pull it out, and I check carefully without bending the solder. I check the angle with the protractor. So I hold it against the flat side there, okay, and okay, seems to be about it. So then I can read off that the angle of my one of the ports in this transfer ports in this cylinder is 10, 20, 24 degrees. So it's upswept 24 degrees, pointing 24 degrees upwards into the bore. And I just do this with all the other ports too. And it's the same with the floors. You just push it in and use the pick to push it up against the floor or the roof inside the cylinder, like that. So this is the port roof. Say this is a port roof. You hold it down the board like this and make sure it's straight, and then you use the pick to push it in and up against the roof. Okay, so this is how I measure the wall angles of the ports. First I draw out a circle that will fit on top of the piston. And since the bore is 40 millimeters, I draw out a circle that is 40 millimeters in the diameter. in the middle of the paper, of course. It's stupid. Anyways, then I cut out that circle. Apply some glue on top of the piston. I glue the paper to the piston top. Then I push the piston with that paper on into the bore. And I try to align the lines, or align one of the lines straight across from the exhaust to the rear transfer port as best as I can. Then I just push it up to the widest point of the transfer ports. If it's the transfer ports I'm going to measure, and when I'm measuring the exhaust I push it up to the widest point of the exhaust. If the exhaust isn't doesn't have parallel sides but are shaped maybe an oval, I can measure at different points to get the right shape or the right angles. Yeah, forgot to mention, I also use this method to measure the port widths and the flow width. The flow width. Okay, so first I take a pen and I carefully mark all the port edges. Like this. Okay, I won't do all of them now, but because this is just an example, but I mark all the edges of the port walls, and this gives me the chordal width of the port. What I do now to find the angle and the flow width is I use a Allen key. I place it inside the port up against the wall, and I kind of wiggle it around until I find the point where it's resting against the wall, and I draw a line there. So that's the angle of the port wall of the A port closest to the exhaust. And then I do the same thing with the other side of it. Okay, it can be a bit fiddly to do this, like that. Like that. So I do this to all the ports. Then I push the piston out of the cylinder and I carefully remove, don't use too strong glue, I carefully remove the paper from the top of it and I stick it down onto the paper, onto a sheet of paper. And then I use a ruler to make the angle lines I drew longer. Like this. I do that with all the ports. But now I can measure the angle between that line, straight line, and the lines I drew for the port angles. So the front edge of the A port is 50 degrees facing rearwards, and the rear edge is about 37 degrees pointing rearwards, or how you want to reference it. When you do this for all the ports, you get a nice diagram which will give you a pointer to how the scavenging will work, where the column will be centered, and how much or how balanced the force from all the transfers will be, or that will give you an idea of how it will behave. And you will also see problems like if this the A port edge is pointing too much or not enough to the rear, you will get a lot of short circuiting. So then you will have to correct it by moving it like this. And the flow width of the ports, which is nice to know, especially if you are going to put it or use it as input for porting programs or simulation programs like Engmod. And then you just check, use a ruler and parallel with or 90 degrees from one of the lines and to the edge of the bore, and then you get the flow width of the port. Yep. That's it. Hope this made any sense at all, or some sense. Please leave a comment and tell me what you think I could have done better here, which is probably a lot. But I hope, and subscribe and click the like button. But I hope that this was helpful for some of you. Okay, thank you.